Hi, this is Joel Gendler at Victory Productions, here to show you our latest prototype for a CEPA, a Curriculum Embedded Performance Assessment. In this CEPA, students will report to the Town Council, giving pros and cons of building a convention center near the sand dunes. All of the activities here are developed specifically with the next generation science standards and Common Core math standards in mind. Students see their assignment, and they are also able to get the rules for the report that they will write at the end of the activities. Students can take notes throughout, and they can use those notes at the end to make sure that they haven't missed anything. Because this is a curriculum embedded performance assessment, they will get lots of content here in a variety of forms. Students will get also periodic assessments. Some will be more interactive than others. Some would be graded by the teacher. There will be case studies. Students can investigate in detail what has happened with devegetation and erosion across the globe. Students can then do activities to see how they learned on the case studies, in this case a drag and drop. Then we get into a bit more meat in the CEPA. There's a simulation and a video that students can participate in. The simulation will involve watching predator-prey graphs or animations. Students explore the effects of changing the population of plants and rabbits. So here we're showing you one time through the simulation, but students would be able to change the starting parameters and play with it again and again. They can look at the graphics or they can look at a graph version of the data.
By driving the deer out of some places and the vegetation recovering on the valley sides, there was less soil erosion because the vegetation stabilized that as well.
So here was a movie they could watch about wolves in Yellowstone Park. And then after watching these two, they can make a list of things that are going to be impacts, both positive and negative, of devegetation. Now here's an open-ended activity. Students are going to actually measure the amount of devegetation in this island in Borneo. They can add a grid to the map, and here they're looking at the blue areas which gained trees. And they can count those areas, and there's a bit of science methodology here. What do you do with the blue squares that are not complete squares? How do you count them accurately? And students can explore that. We're focusing here on the skills, so the counting is actually done for the students. They click on the squares they want to, and then the counts are done for them automatically. But they also have to process this data and realize the number of squares is not the same as the total area. They're going to have to multiply by 4 square kilometers, which is the area of each square. Students are going to do that and enter their data. When they enter the data, it will persist on the following screens, so they don't have to go back and look and see what they did before. So the area that gained trees in this case is 116 square kilometers, and the area that lost is 256 square kilometers. But we point out to students that that procedure really was flawed. Get them to realize why it was flawed and do the activity again, this time getting a more precise and accurate count. When they're all done with this activity, they'll have a truer understanding, and they can go look at deforestation maps and truly understand the research and the measurements that went into the data that they see on those maps. Then students explore soil erosion. There are different interactives, and they come to an activity where they evaluate and revise an experiment. So instead of having them write their own lab, we ask them to improve the existing lab for the purposes of the context that they're working in now. So they might use sand and soil instead of just soil. They might try to measure the horizontal flow of water and measure quantities instead of just making observations. Then students give a benefit for each of these modifications. And again, this is tightly aligned to the next generation science standards. So after students have done this robust set of activities, then they get a checklist for doing their report, and then they can write their report online and submit it to the teacher. They review the checklist, and then they can enter the text, using the notes that they kept throughout the CEPA, and also being reminded to include animations, videos, pictures, using URLs from the internet. We think there are many ways to develop a CEPA that can be engaging for students and also achieve the goals of next generation science standards. We realize also that there are ways to improve this, and we'd love to hear them from you. Please use the comments field, and we'll be sure to respond.